The final type of rock in the rock cycle is metamorphic rocks, and what people don't understand is that these guys used to be one type of rock and it's turned into another, and the only thing that you need to remember is that as it's been turned into another, it's gone through a huge amount of heat and pressure, and because of that this rock has been forced to become harder, stronger, smaller. It's very different than its predecessor. The poor predecessor, imagine it screaming as it was squished over thousands of years, as it's been heated and cooked alive and turned into something completely different than it was before. So here we have precursors or parent rocks which have undergone heat and pressure to literally turn into these rocks. These used to be that. Quite a lot different. The strength properties, they're quite different in hardness and stuff. All of that changes as you heat something up and you give it pressure. And we know that. I mean, if you have, say, a lovely little muffin, and that lovely little muffin gets stuck in the oven, but it gets stuck in the oven a bit too long, it turns into a little yucky looking muffin that isn't quite nice to eat because it tastes a bit charcoaly. Well, if you then squish that muffin, it's certainly not going to taste exactly the same, and it's going to be even harder to chew. And if you then squish it plus cook it, you can imagine how hard it's going to be for your teeth to get through that once lovely muffin when it's been squished and cooked and baked beyond belief. It's now something completely different to what it was before. Essentially, that's what a metamorphic rock is. So those major points that we just did as a recap. Heat and pressure are needed to make metamorphic rocks, but not always both at once. When you just heat something and cook it, it does change it into something new, but it becomes what we call non-foliated if it's just heated. That means the crystals actually start to melt a little, it re-solidifies and grows bigger crystals, but it doesn't have distinct layers in it that we see when we have foliated rock. Foliated rock is rock that has layers in it, and they're very distinct lines and layers, and that tells you that they've also been squished together. So let's go into what are the different types of rock, foliated and non-foliated. Essentially, you have to remember one thing. If it's foliated, it means it was under very high pressure. These guys were screaming as they were squished alive. If it's non-foliated, it was heated, may have been under some pressure, but definitely not high pressures that cause foliation. So they both have a different story. Okay, so non-foliated rock. These are normally ones that are made with a bit of pressure and definitely a lot of cooking. So we often see these along the sides of where volcanoes have pressed through. So this here is what we call an intrusion. It's where magma from below has pushed through the land above, and as it's come out and burst out of this volcano, it's actually cooked the rock as it passes through. The rock where it touched got cooked. So if you had here 3 layers of mudstone, limestone and sandstone, they would have been put down, well, most probably mudstone. Mud tends to get put down in watery environments, most probably from some sort of flood, or the area was actually covered with a swamp or something like that that puts down mud. And limestone and sandstone you usually find when you have oceanic influences, because you have lots of marine organisms with shells and shellfish and skeletons. They dissolve, they fall to the bottom, form limestone, and because it's an ocean, it often will then, well, not often, it always puts sand on top of it, so you end up with this layer of limestone and sandstone together. So that often tells us that an ocean has covered an area when you see those together. Now, as you have the magma push up through here, the mudstone gets cooked into slate, the limestone turns into marble, and the sandstone turns into quartzite. Now, when these do change, you don't see lots of layers of foliation, but you definitely do see an increase in crystal size, and that's because the magma, as it's cooking it, these crystals in these guys actually start to melt a bit, and reorganize themselves and then slowly cool down again, and they grow bigger crystals than were there before. So whatever atoms you have here, they get a chance to recrystallize again in a much larger form. Now this is what we call contact metamorphism, because it's making contact with the rock. And here's an example here. We have limestone here and then marble on top of it, because lava has spread out over the top of this limestone and cooked it and turned the limestone that's between it and the magma into marble. Here's an example of a foliated rock. Notice all the beautiful dark and light lines. That's because the dark minerals are really heavy, the light minerals are much lighter, and when they're put under huge amounts of pressure, they tend to basically group together. So all the heavy minerals will group together, the light minerals will group together, and they form these distinct lines. It only happens under high pressure.